Hey guys, this is Exponential Functions review. This is page 3. In the last video we covered page 2 and we just kind of graphed some basic exponential growth and decay functions. For these two problems we have a little bit more going on, and the difference between these and the last ones we graphed is they have this kind of multiplier out in the front. There's a couple ways to think about this. If we're talking transformations, what this means is we're going to have a vertical stretch by a factor of 5. So if we took the original 2 to the x graph and then we multiplied every y value by 5, that's going to be the new graph. So you can think of it as a transformation. We can also go back and just consider the original problem that or the original format that we were talking about. So remember, at the very beginning of this assignment, I gave you this kind of general template, where this was the initial amount, and this was the growth or decay factor. In this case, it's a growth factor, of course, because it's bigger than 1. Okay, so if we look at this, this would be the initial amount, and this would be like the growth factor. So let's think of it like bacteria, just because we did a bacteria problem in problem number 1. So if I was looking at this function, I would say, oh, 5 is the initial amount. So you're starting with 5 bacteria. So what we can do is we can say 5 is just the initial amount, or it's 5 is the y-intercept. Because let's say that this axis, the x-axis, represents time. It's like how many bacteria there are there if 0 hours have gone by. Well, there's 5 of them, right? So we have the 0.05 for 0 time 5 cells. So initial amount is the amount at time 0, or it's the amount that you have when no time has gone by. Whether it's, we're talking about an investment or bacteria growth or population or whatever it happens to be. So there's your initial amount, okay? The next piece, the 2, that tells you that this guy's doubling, right? So every hour the population's doubling. So what would be the next amount? Well, it would be double 5, right? So 5 times 2 is going to give you 10. So when I go over to hour 1, after 1 hour, we're going to have 10 cells, right? Okay. And then after hour 2, right, another hour goes by, I'm going to double 10. So I'm going to take 10 and multiply it by 2, and I'm going to be up here at 20. And then so on. It would go 40, and then 80, and then 160, and etc. Okay, so you can look at this as, just like a function, right? Initial amount, and then this is the pattern. So think of it like this. When we had linear functions, which this is not a linear function, but if we were to graph a linear function, we would say, oh, b is the y-intercept, and m is the slope. So I start with the y-intercept, and then the slope tells me how to get to the next point. Okay, that's a very similar thing that we have going on here. Right? We don't have to make a table every single time. We can just look at this and say, okay, well, this is your y-intercept, right? Or sorry, excuse me, this one is your y-intercept. It's the starting amount, the initial amount is your y-intercept. And then the b is your growth factor, which tells you how to get to the next point. So start at 5. Cool, that's your first point. And then multiply by 2. And then multiply by 2, and so on. If we want to go backwards, we have to think about negative time. So this doesn't make a lot of sense in our bacteria idea. We can kind of like maybe force it to be. Let's say that you had 5 bacteria at time 0. Well, what was it like an hour ago, an hour before you started the clock? Well, it would have to been half of what 5 was, which would have been 2.5. So maybe this cell is like halfway through dividing, right? Something like that. Okay, and then if you're thinking, well, what about the hour before that? Well, it'll be half of 2.5, which is like 1.25 or 1 1/4. So we got -2 and like 1 1/4. Right, and so on. So going this way to the right, which is like how time is going, right? We're doubling. But if you're trying to think backwards in time, you have to half, right? If I want to go, well, what was it an hour before this? It's half of what it was. It's 10. What was it an hour before that? It was 5. What was it an hour before that? It was 2.5. What was it an hour before that? It was 1.25. What was it an hour before that? It was like 0.68 or whatever it's going to be. Okay, so this gives us a pretty good graph, though. We know we're going to have an asymptote down here at y equals 0, okay? And we're just going to kind of grow exponentially. Okay, and that's our function. Okay. Now, if you really, really wanted to, if you were completely stuck, right, you can always do this. 5 times 2 to the x. Right? So this would be like 5 times 2 to the 0 power. Well, remember, 2 to the 0 power is 1, so I have 5 times 1. Okay, 5 times 2 to the 1. Well, 2 to the 1 is 2, so this is 5 times 2. 5 times 2 squared, right? Well, 2 squared is 4, so 5 times 4 is 20, and so on, right? So you can see that this matches. 0, 5, yep, we got it. 1, 10, yep, we got it. 2, 20, yep, we got it. But we don't necessarily need this every single time once we have like the patterns down. Okay. All right, let's take a look at 7. So if we continue to follow the template that we were talking about, this would be the initial amount, right? So this is halving. We have something that's like, multiplying by a half every time. So this is going to be a decay function because our growth factor is between 0 and 1. But it's going to start at 4, right? That's our initial amount. So maybe we can talk about this like value of something, right? The value is a half of what it was the previous year, right? I mean, that's a pretty intense decay factor, but that's okay. So after 1 year, we're going to have half the value, right? We're going to have $2 or whatever. After 2 years, it's going to be half of that. It's going to be $1. And then after 3 years, it's going to be 50 cents, right? And so on. So again, this gives us our starting place. This is our initial amount. This is our y-intercept. Okay. The second number is going to be our growth or decay factor. In this case, it's a decay factor. Over here, it would be a growth factor. And we're halving here. So we go 4, 2, 1, a half. Okay. But if I wanted to go backwards and look backwards in time, 4 is half of what it was before. So it must have been 8 before. Right? But 8 is half of what it was a year before that, so it must have been up here at 16. So going in the right direction, like time is going by this way, right? So we're halving. But if we want to go back in time or look back in time, we have to like double, kind of going this way. But let's just make sure it makes all sense. So like 2 years before you bought it, or whatever, that doesn't really make a whole lot of sense, but it's at $16, let's say, $16 worth. And every year, the value halves. So 16, 8, 4, 2, 1, half, and so on. Okay. So again, you could make a table for this if you wanted to. Right? X, 4 times a half to the x power. Of course, you're going to have to deal with fractions and negative powers, but if you had 4 times a half to the 0, what's a half to the 0 power? It's 1, so this is going to give you 4, right? 0, 4, that's right. If you have 4 times 1 half to the 1 power, what's a half to the 1 power? It's a half. So 4 times a half is 2. 4 times a half squared. What's a half squared? It's 1 half times 1 half, which is 1/4. So what's 4 times a fourth? It's 1. Right, and so on. These get tricky right here in the negative land, but you can make a table if you need to. But you don't have to if you understand what these two numbers represent. They're the initial value and the growth or decay factor. Okay? All right, in these two problems, we're going to basically be going backwards, right? So we're going to write a function here, write an equation. Okay, so we just need to find two things. We need to find the initial amount or initial value, and we need to find the growth or decay factor. In the case of number 8, it's going to be a growth factor, obviously, because it's as we go to the right, it's getting bigger. So let's grab those pieces, right? So let's find our initial amount. That's our y-intercept, right? Y-intercept. So at 0 time, we can think of this as bacteria again if we wanted to. At time 0, we have 3 bacteria. Okay, so the initial amount is 3. Let's see what's happening. So when we go from here to here, we have 6 now. After 1 hour, we have 6 bacteria. After 2 hours, we're going to have 12 bacteria. Right? So you see what's happening here? 3 times 2 is 6. 6 times 2 is 12. So we're doubling again. Doesn't have to be double, just happens to be in this case, because if you triple or quadruple, the graphs get out of control pretty fast. So the growth factor here is 2. We're doubling. So f of x is equal to my initial value times my growth factor, and then you have your exponent. That's it. Okay, let's look at this one. Same idea. Let's start with our initial amount, okay, our y-intercept. In this case, the initial amount is 5. Let's see what's happening. 5, and then the next one looks like it's at 2.5. And then maybe 1.25. But let's say we didn't know that. Let's say that doesn't look like a very nice point. Okay, cool, no problem. Let's go backwards. So 5, we go back 1. Looks like we're up at 10. We go back another one. Looks like we're up here at 20. So we got 20, 10, 5, 2.5. Looks like we're halving here, right? So we have our initial value, initial amount, or our y-intercept, in other words, and then the growth or decay factor. This is obviously going down, right? We're looking this way because time is going this way. So what's happening as we go to the right? We're halving. Okay. Now you can use parentheses around your fraction. You can use a dot, for multiply if you want. You can do this. Okay. But just so we're clear, this is not going to be 6 to the x. And the reason why is order of operations. You might see, oh, 3 times 2 is 6, right? 3 times 2 is 6, but we have to do whatever 2 is to the x power first, and then we multiply that result by 3. Right? Exponents come before multiplication in the order of operations. So we kind of have to keep it like this. We can't simplify it, even though we might want to, because the order of operations, we don't know what x is yet. X can change. All right, that's page 2, or 3, excuse me. Now, one thing I wanted to be clear about is that we don't necessarily have to have 2.5, we don't have to have a growth factor that's 2 and 2. Right? That's just kind of a coincidence. It could be 3. So let's say we started at, 2, and then we went from 2 to 6, and then 6 to 18. That would be tripling, right? 2, 6, 18. So it's not always just doubling or halving. You could, have a factor of 3 or a factor of a third. You just got to figure out what it is for your particular graph. Okay, we're going to come back and look at page 4, which is the last page of this guy. And hopefully that will get you all refreshed and remembering how to do these.